And shell method is saying, I'm sorry, hold on 1 second. Shell method is saying, okay, let's cut it. Let's cut horizontally. Then let's find the area of this piece. Let's approximate with this kind of rectangle. But in here, we approximate with rectangle. Right after we cut, we see we have rectangle. We approximate with this, right? We have 2 pi r times h. Then we add up all these areas. So here, well, because we're rotating with y-axis, of course we can rotate with x-axis, right? When we rotate with y-axis, then we cut this way. We cut this way. We try to find the area of this. Then we add them all up, right? The thickness. Imagine the thickness. We add them all up. Okay, let's find. So you see here the volume equals circumference times height, which we think as a width, right? As a width, then times the thickness. Okay. Let's look at this picture. So let's see we have this piece of region. Then when we rotate with y-axis, we get this solid. Okay, this solid. And of course, the inside here is hollow, right? Hollow inside here. So you see the inside, the cylinder inside is hollow. So we want to find the volume of this. So what do? We want to cut. Well, let's cut this way, right? Let's cut this way. Then we evaluate the areas of all this, then add up all the areas. Right? You could think this is a piece, right? So we will have 2 pi xi bar, or imagine this is the radius, right? Times f of x bar, which is the height. Right? This is the function. Right? The height is f of x bar, the function value. Then multiply by, we cut along from A to B, right? Cut along infinite many pieces from A to B. So the integration is, in the end, is this. We cut along x-axis infinite many pieces from A to B. Then 2 pi x, because the radius is just x value, right? You will see this point, the radius just this. You see this point, the radius is just this. Right? So have 2 pi x, right? 2 pi, the circumference of each circle is a 2 pi x, or 2 pi r, the r is x. So circumference 2 pi x. Then what's the height? What's the width? Right? In this is the height, f of x, right? The function value, the y value. Then we're cutting on x-axis. Right? So we integrate from A to B and cut from A to B infinite many pieces. Right? 2 pi x circumference and the height, and add up all those areas. Right, this is a visual picture, right? So we cut, if we have cylinder like, we cut from somewhere, we cut, Then we laid it out. We see we have this. Right? Looks like a box, rectangular box. So we have length. The length of this box is 2 pi r, which is x in this case by rotating with y. And the height is function value, f of x, function value. So this is just one piece of it. This is just one piece of it. Then dx, right? Delta x dx, so we're cutting along x-axis. Okay, let's see example 1. Find the volume of the solid obtained by rotating about the y-axis, the region bounded by two functions in this case. Right? One function is 2x squared minus x cubed. Another function is y equals 0. Well, y equals 0 is x-axis. Right? So bounded by x-axis and this function. And this function we draw, we get this. Get this. Get this. So we want to rotate this along y-axis. After rotation, we get this 3D picture. Right? We want to find an area of another area, the volume of this solid. Volume of this solid. And which means not including this hollow. Right? So the middle is hollow. Well, all we have to do is to figure out 2 pi r, the circumference of each circle. So this is a picture for one piece. Right? Let's say at this piece, right? At this piece, at this point. So we want to evaluate the area of this piece. Then rotate, right? Rotate this piece to get a cylinder-like. To get a cylinder-like. All right. So 2 pi r, right? 2 pi x, because we're rotating with with y-axis, so the r is clearly just x value, right? You see the r, the rotation happens with y-axis. The r is just x value, so we have 2 pi x. Then the height of this, or the thickness of the rectangular box, right? So this width or h with just this function value, right? So this function value at this point. See that? It's f of x. F of x is 2x squared minus x cubed. Or sometimes they use y, sometimes they use f of x, right? We are just, for us in the function world, we're just equaling y with f of x. So f of x equals 2x squared minus x cubed, right? So that's h in the beginning, or just f of x function value. Then we're cutting along x-axis from a to b. Well, how do we figure out from a to b? Right? Those two functions, the intersection of those two functions, we just set this one equal to 0. We set a 2x squared. Let's do. So where do those two intersect? We have 2x squared minus x cubed equals to 0. Equals to 0. Y equals 0. Then we solve this. So we factor out x squared. Then we have 2. So 2x squared minus x cubed. We'll factor out x squared. So have 2 minus x equals to 0, right? That gives us x equals to 0 and x equals to 2. We find the intersection of those two functions. So they intersect at 0. They intersect at 2. So 0 is our lower limit. So we're cutting along x-axis from 0 to 2. So we integrate from 0 to 2 along dx, right? Along x-axis. And 2 pi r is just x, and times the function value f of x. The rest are just do this integration, calculate this integration. So 2 pi is a constant, factor out the integration. And then we just have multiply x into f of x. So get 2x cubed minus x raised by 4. Use power rule antiderivative. So get 16 over 5 pi. Right? So this is called a shell method. Anybody has any question? Okay, let's see this one. Example 2. We want to find the volume of the solid obtained by two functions also about the y-axis. So one is equals to x, another one equals to x squared. So when we draw the picture, we have y equals to x, this line, and y equals to x squared, this curve, right? So of course this goes, infinite, goes to infinite. But we need to find where do they intersect. Always find the intersection because enclosed by those two. So we set those one equal to each other. So we'll get x equals to x squared. Or move to the same side. So get x squared minus x equals to 0. Factor x, get x minus 1 equals to 0. So we get x equals to 0 and 1. So we have our integration from 0 to 1 along x-axis. Then the rest just 2 pi x and the function value, right? 2 pi x, 2 pi r again is the x, right? R again is the x. So sometimes this is a little confusing. Sometimes, students tend to do the minus. Students think about, okay, r is this, right? This function minus this function. No, we're not using the method anymore. We're using the method of this. We're using the method of this, right? We're trying to find the area of this, or approximate area of this. Then we rotate. So we'll get 2 pi. So we'll get 2 pi r. 2 pi r. All right. So you see, r is always the x value. So convince yourself, if you try to use the shell method, convince yourself not to confuse with disk method. According to my experience, students get confused with the washer method. So that's why I said, as long as you know how to use washer method, you don't really need to know to use shell method. Sometimes it's kind of confusing. But it's always good to know, one more method. So 2 pi x times f of x, cutting along dx. So the rest is just calculation, right? So after we calculate, we get a pi over 6. Let's see the third example. Using the shell method to find the volume obtained by rotating the area enclosed by y equals the square root of x from 0 to 1. Okay, this is given lower limit, upper limit. Or this is about the x-axis, all right? So this is an example about rotating about x-axis. So after we rotate, they did not give a 3D object, 3D. So after we rotate, then we will get a picture like this. If we cut it vertically, we see we have this. The intersection, so have this kind of shape, 3D object. Okay, so square root of x, right? So y equals square root of x, or can be seen as x equals to y squared, right? Now we're rotating over x-axis. We're rotating with the x-axis. So cut this way. We evaluate, we approximate this way. Then we see a cylinder this way. I'm trying to draw a symmetric piece. Just think about symmetric piece here. Then we see this, right? We see a cylinder like it goes this way. A vertical, this kind of a horizontal cylinder, right? Okay, so we need to find the 2 pi r, right? Circumference of this circle. Circumference of this circle. Then times height or width, which is this one, which is this piece, right? Then we're cutting along y-axis, right? We're cutting along y-axis. So we have this piece, we have this piece, we have this piece, this piece. We're cutting along y-axis. So cutting along y-axis from 0 to 1. And 2 pi r we see when we rotate this way, r is the y value, right? So r is y value. And then what's the width of this? The width of this we see is from here to here, up to here, right? It's from here, so that this becomes the width or the height of this horizontal cylinder like, which is this value 1 minus y squared, right? Because y equals the square root of x, we can rewrite as, so this curve can be written as x equals to y squared. Because we're cutting along y, so we want the integrand to be represented as function of x in terms of y, right? So we rewrite this function y equals to square root of x. We square both sides, basically we solve for x. So this one can be written as x equals y squared, right? X equals y squared. So the height of this, or the width of the rectangular box, or the height of this cylinder, like, is 1 minus y squared. So we have this. So I have 2 pi y times 1 minus y squared d. We're cutting along y-axis, right? We're cutting along y-axis. We have all those rectangular box goes this way, right? Okay, so the rest is calculation. So in the end, we'll get a pi over 2. What you can do is you could use, if you really want to, get the idea of this method, you also can use washer method. You do two different methods, all right? With the same question, you do washer method, then you try shell method. If you get the same answer, you did right. So let's say last example. Find the volume of the solid obtained by rotating the region bounded by this. So one function is x minus x squared. The other function is y equals 0 with x-axis. About the line x equals 2. So this is not about x-axis or y-axis. So it's about a line, x equals 2. So x equals 2, this. And the bounded by this, the 2 function, we get this piece. Again, we can set this one to equal to each other. Then we get x equals 0 and 1. So from 0 and 1. So we have this piece, so this piece, right? So we want to rotate this piece about x equals 2. Right? Then we see a cylinder like hollow cylinder this way. Hollow cylinder this way. Because x equals 2 parallel to y. So the idea is similar to cutting along x-axis, right? Cutting along x-axis. But the radius will change. Because you see this circumference, right? The circumference, you see the radius now, it's this, right? Choose one point to see the radius. The radius is this. But the idea stays the same, okay? The idea stays the same. So we're cutting along x-axis, and from 0 to 1, right? Which we set those two equal to each other. We solve for x equals to 1, 0, and 1. Then 2 pi r. Well, what's r? What's the radius of this? We see that's a 2 minus this function, right? 2 minus x. 2 minus x, right? Because this is, let's see, this is x. Oops. So let's say up to this point. Let's do one little longer one. Oops. Right. Let's do a longer one. Right. At here is this. Well, let's go along with that picture. Okay. Go along with this picture. But if it's point here, we say it's here, right? Let's go with the picture. So 2 minus x value. And then what's the thickness? What's the height of this cylinder? The height of the cylinder is just a y value, right? Just this one. Just a function value. The thickness of this, or the height of this cylinder like is this piece. It's the function value. So it's f of x. Then dx. So the rest is just calculation. The rest is easy. It's just about to figure out the r. Okay. Figure out 2 pi r, well 2 pi is constant. It's just about to figure out the r, the radius of the circle, and the height of the cylinder like. Right? The height of the cylinder like. Okay, as I said, 7.3 is optional, so I'm not going to leave you exercise for this. But maybe you still have online homework to go with, and also the quiz. Okay, anybody has any questions? So we still have time. Okay, let's do this. You claimed those in the beginning, so let's go with the review sheet, all right? I think we're ready for review sheet. So this method, right, it's optional. If you want to know it, it's good. If you think you know Washer method, that's enough. You don't have to go with this shell method. All right, let's go to a review sheet, and also you prepared for it. So we're going to go with the chat. Amir can do 9. Anybody wants to do 1? If maybe we can do by order. Okay, Amir ready for 9. Jason wants to show 1. Oh, I see Jason claimed the 1 first. So Kaiser, you have to. Oh, Kaiser said you said first, Kaiser. You know what? Let's go through the chat. All right, go through the chat. So Amir, are you ready for 9? Then Julia.
Yes.
Julia 17. Okay. Julia 17, Carlos 3, Emily 22, Kaiser 1, right? Kaiser claimed before. Kaiser 1, Karen 14, Angel 15, Alexandra 13, Henning, oh, Carlos already claimed 3, Victoria 8, Henning 2, oh, hold on. Julia asked me questions. Sorry, I didn't see this. Why is the radius x minus 2? Two minus x. Julia, that's still your question, right? Why is it 2 minus? Okay, why is it this 2 minus x? All right. So we want to approximate 2 minus x. You see this one? Let me see if I can draw a square. So imagine here, imagine it's all about to figure out this what do we call it? Cylinder, right? Julia, you see this cylinder, right? We want to approximate the volume of this piece. So what's the volume of this piece? It's the length times the height times the thickness, right? So how do we say it? We cut. I think you did not get the idea of this. Okay, think about it. So this is a cylinder piece, but the inside is hollow. So we want to find out the volume of this piece. So how do we do it? Shell method is saying cut somewhere. So cut it, then lay it out. So we cut this piece, we lay it out, we see a rectangular box. Then the rectangular box, how do we find the volume of this rectangular box? Which is the length. Length is 2 pi r, right? In this case, it's 2 pi x, 2 pi r. The r of the rectangle, the 2 pi r. And then the thickness is, this is the width, right? The width. So length and width. Okay, now remember that. Now come to this piece. You see this? What's the, so what we need to figure out 2 pi r and h. So think about this 2 pi r h. H is the height of this, right? So 2 pi r h. So we start with this. So we need to figure out what's r. Let's see what is r of this cylinder. Okay, you see I draw here, right here, the red color for this piece. For this piece, you see this is 2. It's from this point. Can you see my pointer? Okay, it's from this point up to 2, because we're rotating along x equals 2. So that's the radius. Make sense? And this radius is 2 minus x value. Where is x value? Let me use another color. All right, so it makes sense, right? Because you see this is the x value up to here, up to this point. That's the x value for this point. That's why it's 2 minus x. Okay. All right. Okay, anybody else has any question? Let's see. Okay, that's it. Okay, Amir, you ready?
Yes, Professor.
Okay, always remind us, everybody always remind us the question. Start with the question.
Okay, so for number 9, we're asked to find the first derivative of each function, and the function we're given is f of x is equal to square root of 3 minus 2x. And all we're doing here is using the chain rule. So if we use a f and a g, you could say that our f is this outer, that's square root of x. And then we know that our f prime would be 1 over 2 square root of x. And then we also have our g, that's our inner function, that's 3 minus 2x. And then we will also find our g prime. Derivative of a constant is 0, and negative 2x, so it'll just be negative 2. So from here, we have your f prime of g of x times g prime of x, this is the chain rule, and then all we do is evaluate this. So we would have your 1 over 2 square root of 3 minus 2x times the derivative, that is negative 2. So then from here we would have negative 2 over 2 square root of 3 minus 2x. And then we see we can simplify it. So you get your negative 1 over square root of 3 minus 2x. And this right over here is our f prime.
Okay, great. But if we want to make it perfect, we would add f prime of x starting from this point on. F prime of x equals to, well, we'll think of this as f of g equals this, then equals this, f prime of x equals this.
Oh, I understand, Professor.
This,
okay.
Right?
Yes.
Then equals to this. That would be perfect.
Yeah.
Okay, anybody has any question? And also one more, usually we leave the negative sign up here in front of the fraction.
Okay, Professor.
Okay. Anyone has any questions? So this is a typical question about the chain rule, right? Look at this function f of x as f of g of x. So f as a, or maybe think about h, right? Think about h, something like that. Okay, anyway, so this is applying chain rule, which is a great. Thank you, Amir.
Thank you, Professor.
Okay, let's see. Next one, Julia, 17. So if anyone has any question, feel free to jump in, all right, to ask questions. But sometimes you type in the chat. Sometimes I forget to look at it. Ahini has trouble with the internet. Of course, you can present another time. But the problem is, you know, for the review sheet, if someone presented already, I showed no mistake, we cannot present the same question. We have to choose a different question to present. Like this, right? Amir already did 9, so nobody else can do that anymore because he did it perfectly. Okay, so this is.
Sorry, Professor, I don't know if you can see it. I think it's loading in.
Oh, Julia, right? I see 17. Yes.
Okay.
I see.
So for question 17, they asked you to find the difference quotient for the function 2x minus 3 over x plus 1. So I started by separating each value of the difference quotient. So f of x is 2x minus 3 over x plus 1. F of x plus h. So you just input the value of x plus h into f of x. So it's 2 times x plus h minus 3 over x plus h plus 1. And when you simplify, it's 2x plus 2h minus 3 over x plus h plus 1. And then I calculated the difference between f of x plus h and f of x. So I just input those values that I got earlier. And so what you want to do is try to have both of the fractions to have the same denominator, so it would be easier to simplify. So for f of x plus h, you multiply by x plus 1, both numerator and denominator. And for f of x, you multiply by x plus h plus 1. And then at the bottom here, when you simplify, you get 2x squared plus 2x plus 2hx plus 2h minus 3x minus 3. And then minus 2x squared plus 2hx plus 2x minus 3x minus 3h minus 3 all over x plus h plus 1 times x plus 1. And then I continued to simplify. So we so 2x squared, they cross out. Same with 2x and 2hx and the constant -3. So all you're left with is 2h plus 3h in the numerator, and the denominator stays the same. So you get 5h over x plus h plus 1 times x plus 1. And then over here at the top is my final calculation of the difference quotient over h. So just to easily simplify, you can do the reciprocal of h, so that's 1 over h, and then the h is crossed out, so you're left with 5 over x plus h plus 1 over x plus 1.
Okay. Okay, anybody has any questions? Let's see from the chat. Oh. Okay, looks great. But Julia, you see I put parentheses around the two expressions.
Yeah, I think I just forgot to put them. I also forgot to put one of the parentheses in the answer.
It's important to put parentheses around, right? You're multiplying everyone with x plus 1.
Right. Yeah, that's my fault.
Yeah. No, it's okay. It's okay.
Okay, thank you.
Great, Julia. Anybody else has any question with this? This is great. The differential quotient. Okay, that's Julia. Then Carlos, number 3.
Yep. I'm just gonna load up the picture now.
Yeah, we see your I see your picture.
Yeah, I'm sorry, I cannot see it now.
Okay.
Let's see if it's loading. Okay, I am not able to see it, but I can explain it. Is that okay?
Okay. Okay, sure.
Okay, in this case, what I like to do sometimes is that I like to replace, we can find the value when we plug in 0 to see if it works. And in this problem, it did work. Yeah, I don't know why it did limit. Yeah, so I use plugin for 0. So 0 in this case really works. So we replace x for 0 values, and we get cosine 2x, of course, 0. And let me see if I can get a pointer here. We get 0. We just plug in all the x values, and cosine 2 times 0 in regard to it, it's 1, the identity, and then we only get I don't know if we do the math here, we skip the -9n. So our answer is limit x approaches 0, it's -19.
So right here, I see your answer is
Yeah,
right. You have a good approach, right? I like what you said. You said, okay, I like to see if 0 when x approaches 0, if 0 is in the domain of this function, just plug in.
Yep.
So plug in, you said it works, right? It works means it does not cause the denominator to be 0.
Or the numerator or the denominator, 0. Yeah.
Right. So you just plug in x to be 0, then you get the limit when x approaches 0 of -1/9. But what's your final solution? I still see limit x approaches 0 here.
Here it's on the corner, -1/9.
Oh, I didn't see that. So, right, okay, so let me read for you. So the final answer is -1/9 without the limit sign, because the limit of a number, just the number itself,
Oh, okay. Yeah.
right, equals to -1/9. Okay, anyone has any question for this? All right, thank you, Carlos.
Thank you.
Next one. I think Emily, right? Oh, Emily, yeah, okay, Emily is not ready yet. So let's see who's after Emily. Oh, I see number 1 here. Who has number 1? Oh, Kiza. Kiza, that's your number 1, right?
Yeah. So I had number 1, and we're asked to find the of x approaches 0 sine 5x divided by x times 4x squared minus 8. So we can solve this both ways, either using L'Hopital's rule or just using a limit identity, which is sine x over x equals 1. So I'm going to go with the limit identity route. So we can split up the limit into 2 parts. So limit from x to 0, we can take the limit from x to 0 of sine 5 of x to x times the limit of x to 0 of 1 4x squared minus 8, and we can separately solve those. And when I solved, I got 5 for the limit x approaches 0 sine 5 of x over x, and for the limit of x approaches 0 1 over 4x squared minus 8, I got -1/8, and then I multiplied those two together, 5 and -1/8, and got -5/8.
Great, Kiza, can you also talk about you using L'Hopital's rule?
Yeah, so for L'Hopital's rule, it's a shortcut. So I just took the derivative of the top and the bottom and got cosine 5. The derivative of the top is cosine 5x times 5, chain rule. And for the bottom, I got 12x squared minus 8. And then I just substituted in 0 and got -5 over 8, the same answer.
Great. Anybody has any questions? This is beautifully done. Anyone has any questions? Right, so in class, I emphasized on using this identity. Right? This is a very important identity. Oops. Limit when x approaches 0, sine of the angle. Right? This angle can be any expression. Does not have to be x, only could be 5x, 7x, or some other expression, right? Over the angle. So sine of the angle over the angle equals 1 when x approaches 0. When the angle approaches 0. When the angle approaches 0, sine of the angle over the angle equals 1. All right. So here we have sine 5x. So the angle is 5x. If x approaches 0, of course, 5x approaches 0. Right. So Kaiser is trying to use this identity. He's saying Okay, the angle is 5x. I need to manufacture 5x in the denominator because sine of the angle over the angle equals to 1. So he multiplied by 1, then he get a sine 5x, factor out this 5. So that equals to 5. Then the other expression, there's no problem. We can plug in x equals 0. So get negative 1/8. Then in the end, he gets negative 5/8. Or another very popular method in mathematics is called the L'Hopital's rule. L'Hopital's rule is saying limit when x approaches, for this question, x approaches 0 of the function of a rational function, rational-like function. That means the numerator is a function of x in terms of x. The denominator is a function in terms of x. Then the limit of that equals the limit of the numerator, derivative of the numerator divided by the derivative of the denominator. So we just take a derivative of the numerator and we take a derivative of the denominator. So that's this method on the left. So derivative of sine 5x, that's cosine 5x times 5. And derivative of the denominator is 12x squared minus a. So the limit of the original one equals the limit of this one, right? Let's see now, can we substitute x into 0? Right, yes, right? By doing so, 0 now is in the domain of this new manufactured. Let me change the color, right? Into this new manufactured function. The numerator is a derivative of the previous one. The denominator is a derivative of the previous denominator. So this is called the L'Hopital's rule. L'Hopital's rule can only be used for indeterminate, something like this, 0 divided by 0. Right, form only can be used for this kind of form. So in the end, right, he put 0 in, so we could put an equal sign here. Because once we put x into 0, can put 0, so we have this. So the limit equals negative 5/8. Perfect. Okay, thank you, Kaiser. Next one. If anyone has any question, feel free to jump in. Oh, right, I need to make you presenters.
Can you see that?
Yeah, so this is 14.
Yeah, for 14, you're told to find dy over dx, and then they give you the equation 2x cubed minus 5xy minus 4y cubed equals 1 minus 2x squared y. And basically what you want to do is you differentiate both sides equation, like the entire equation, in terms of dx. So that gets you 6x squared minus the equation of 5y plus 5x dy over dx plus 12y2 dy over dx equals negative 4xy minus 2x squared dy dx. After that, I just distributed the negative sign on the left side of the equation. And then after that, you want to group the numbers with the dy over dx on one side so you can factor it out later. So I grouped those numbers on the right side, and that turns into 6x squared minus 5y plus 4xy equals 5x dy over dx minus 12y squared dy over dx minus 2x squared dy over dx. Factored out dy over dx and then divided the left side of the equation by 5x minus 12y squared minus 2x squared. And that gets you 6x squared minus 5y plus 4xy over 5x minus 12y squared minus 2x squared equals dy over dx.
Okay, anyone has any questions? So this is implicit differentiation. So we do not have a function, right? Here we have an equation. We have an equation. And this equation is difficult to be written as a function of y in terms of x, or as a function of x in terms of y. So we need to find dy dx. I think also you could use a notation y prime, all right? You know, if you don't want to write too much, you could use a notation of y prime. So implicit differentiation is saying we can find derivatives in terms of one variable, right? So in this case, we're trying to find dy dx. So we want to differentiate this equation in terms of x, right? So when we take a derivative of 2x cubed, we follow the same differentiation rule. So that's 6x squared. 6x squared, then we have dx over dx, or dx over dx is just 1. It's just 1. So we don't have to write it. So when we take derivative with x term, because here we want to find out the changing of y in terms of x. So just 6x squared. But when we differentiate with the term involves y, we have to attach dy dx or y prime. So for xy, we follow product rule. All right. So for this also x squared y, we follow product rule. The only difference is when we differentiate with y, we multiply by dy dx. We multiply by dy dx or y prime. Okay, great. Thank you, Karen. Next one. This is a 22.
Professor, can you see this?
Yeah.
Okay, I can't see it. So for question 22, it is to evaluate the integral of sine 7 minus 4x. So I use the substitution rule. I let u equal to 7 minus 4x, and then I have to find the derivative of that. So du dx is equal to negative 4. And then I have to solve in terms of dx, so that will equal to negative 1 over 4 du. Now I plug that into the original equation. So negative 1/4 integral of sine u du. Integral of sine u will equal to negative cosine u. So then afterwards I will plug everything back in, which will equal to cosine 7 minus 4x over 4. And then since this is an indefinite integral, I have to add the letter c. So that's my answer over there.
Okay, so we should add a c from this moment on after integration. So the rest is a simplification, right? You see, third step, you see here, the third step, equal sign. We should add c. After integration, we should add c. We should add c right away. So this is the infinite integral. Okay, great. Anybody has any questions? Okay, so this is Emily, right?
Yes.
Okay. All right. Thank you, Emily. Okay, next one. This is question 15. Angel.
Hello, can you see it?
Yeah.
It's loading for me. Oh, here it is. So for this question, we need to find dy over dx or y prime. First thing that we have to do is to find the derivative of both sides. To find the derivative of sine xy, we need to use the chain rule. We get it on the right side. First, I determined f of x, which is the outer function, equals to sine x, and then derivative of that is equal to cosine x. And then g of x, the inner function, equals xy, and then the derivative of that equals 1 times y plus x times 1 times y prime, since we have to multiply derivative of y by y prime. And so that equals to y plus xy prime. And then to find the derivative of sine xy, we just plug in those values into the formula f prime g of x times g prime of x. I plugged in and got cosine xy times y plus xy prime. And from this point, I distributed cosine xy and got y cosine xy plus xy prime cosine xy. So that's the derivative of sine xy. And for the right side, x squared minus y, I found that the derivative of that to be 2x minus 1 times y prime. And then the next step is to combine the terms with y prime. I move y prime, negative y prime to the left by adding y prime. And then I move y cosine xy to the right. And then I factored y prime out and got y prime times cosine xy plus 1. And then divide the whole both sides by x cosine xy plus 1. And so the final answer is y prime equals to 2x minus y cosine xy over x times cosine xy plus 1.
Perfect. Anyone has any questions? Good job, Angel. Thank you.
Thank you.
Next one.
Good morning, Professor.
Good morning. Okay, so this is a 13.
Are you able to hear me?
Yeah.
Okay. So this is similar to the last problem. So we have to find dy dx, or y prime, and the equation we're given is tan of x times y is equal to x squared minus y. So for the
Oh, we lost you.
product.
Okay, you came back. Yeah, you came back.
I did. You could see the
Yeah, it's
word.
on and off. We lost you again.
Okay.
You are back again.
Okay. So I know that for tan of x times y, the derivative would be secant squared x times y, and also you'd have to use the product rule for x times y, which is x times dy dx plus y, and we know that the derivative of x squared minus y would just be 2x minus dy dx. So next what I had done was distributed secant squared of x times y into x times dy dx plus y. And then after that, I had added, in order to get dy dx onto one side, I had added dy dx from the right side so that it would be on the left. Next, I subtracted secant squared of x times y onto the right side in order for dy dx to just be on the left side. So since all components of the equation of dy dx are on the left side, I factored out. So after factoring out dy dx, the component in the parentheses would be x secant squared xy plus 1. And then you divide that, and then your final answer for dy dx would be 2x minus y times secant squared of x times y over x secant squared of x times y plus 1.
Okay, anybody has any questions? Okay, looks like we're really good at implicit differentiation. Great. All right. Okay, thank you, Alexandra. Next one.
Good morning, Professor. I posted my number on the chat.
Okay, someone just speak. Is that Victoria?
Yes, I'm doing number 8.
Oh, number 8. Okay.
Yeah, I have trouble uploading the picture, so I just typed it in the chat.
Okay, explain.
Okay, so for number 8, it asks to find the limit as x approaches infinity of 3x squared minus x minus 2 over 5x squared plus 4x plus 1. And for this question, I used the ignore rule where you ignore the lower terms for the numerator and the denominator. So then I will just get 3x squared over 5x squared. And then you could eliminate x squared on the top and the bottom. So then you would get 3 over 5 as the answer.
Okay, so whenever the expression still involves x, you still need to carry on the limit sign. You still have to have a limit of x approaching infinity.
That's right. That's right.
Okay. All right. Okay. Thank you, Victoria. Right. When
Thank you.
x the variable approaches infinity, we can use ignore rule. And for 3 over 5 is actually the horizontal asymptote or the range of this rational function. The rational function, the range of this rational function is any real number, but not 3 over 5. All right. Okay, thank you, Victoria. Next one. So this is number 10. I see number 10 on the screen.
Hello, Professor.
Yes.
Okay. So number 10 asks for to find the first derivative of the equation. So sine 2x over 1 plus cosine 2x. First I use quotient rule. So it's d over dx sine 2x times 1 plus cosine 2x. Then with derivative of 1 plus cosine 2x, then times sine 2x over 1 plus cosine 2x squared. So for sine, wait, can I write it? For sine 2x, when we find the derivative, I use chain rule here. So first we find the derivative of sine 2x, then we'll find the derivative of sine 2x, just 2x itself. So it becomes is that here? So it becomes 2 times cosine 2x and times 1 plus cosine 2x minus negative 2 sine 2x over 1 plus cosine 2x squared. So if like minus and minus becomes positive, and a negative 2 sine 2x times sine 2x becomes 2 sine squared 2x. So the result is 2 cosine 2x times 1 plus cosine 2x plus 2 sine squared 2x over 1 plus cosine 2x squared.
Okay, Ray, good. Can we simplify this expression?
Yes, times 2 cosine 2x to times this with this.
That's right.
Yeah, I think.
So let's simplify it.
Hold on a second. So it's gonna be 2 cosine 2x plus cosine 2x, and then is 3 cosine 2x.
No. You have 2 cosine 2x times 1. That gives you first term 2 cosine 2x.
Yeah.
Then
Yes.
2 cosine 2x times 2.
Oh, right. It's cosine times 2 times cosine 2x. I missed that.
Right.
Sorry.
So you get 2 cosine square of 2x.
Yeah.
Then 2 cosine
Oh,
square plus 2 sine square. What do you have?
so it's 2 cosine 2x 2x times 1 becomes 2 itself, and then we plus 2 times cosine 2x times cosine 2x. Depends on working. So it becomes 2 cosine 2x times cosine 2x. It becomes 2 cosine square 2x.
Mm-hmm. Then you have 2 cosine square of 2x plus 2 sine square of 2x.
Yes.
And that 2 combines to be, remember, cosine square plus sine square equals to? Very important trig identity.
1 plus cosine?
No, sine square of the angle plus cosine square of the same angle equals to Pythagorean theorem.
Oh, equals 1.
Equals to 1. So can you apply that for this? You have 2 cosine square plus 2 sine square.
So I believe it becomes 2.
Right, comes 2. So the numerator, you have 2 cosine 2x plus 2. Then the denominator, you have 1 plus cosine 2x square. Can you simplify that? Let's erase this.
Professor, can you repeat the questions?
Okay, so now can you write down what you have so far?
Okay, so 2 plus, okay, it's 2 plus 2 sine square 2x or 1 plus cosine 2x squared.
No, the numerator, you don't have a 2 plus 2 sine square 2x, right? Look at this. You multiply those two. You get 2 cosine square. Then you combine with these two. With this one, you get 2. But what's left? This one is left. 2 cosine 2x plus 1 times 1.
Okay.
So this should be 2 plus 2 cosine 2x, right?
Mm-hmm.
Now, can you simplify it with your denominator?
Okay. Can I just do on the worksheet by myself? Like
Oh, sure. Well,
yeah,
but
just
if
give
you
me a
see it,
second.
okay, anybody else see it? Yeah, just do step by steps because this can be simplified. Right, factor out 2 in the numerator. Oops.
Oh, okay. I think yeah, find out. So
Okay.
so the numerator becomes 2 cosine. Wait, there's no eraser. So it's 2 cosine 2x plus 1 over
Plus 1 or plus 2? Oh, you factor out
times 2 outside. So I left out 2. So it's 2 cosine 2x plus 2. And over I rewrite this as cosine 2x plus 1 squared.
good.
So we can cancel the top and bottom. So it becomes 2 over cosine 2x plus 1.
Perfect. Okay, great. All right. Thank you, Ray.
All right, thank you.
Okay, next one. Okay, I think it's Rohini.
Yeah. For this one, they're telling you to find the limits.
It's number 2?
Yeah, number 2.
Okay.
And since the limit is x is going to infinity, you can just look at the highest power, which is the degree of it. So I just looked at.
Yeah, let's call it leading term. Leading term.
Okay, the leading term. So I just looked at that. So it would be 3x squared over, since you the square root of x to the 4th is x squared, and 2 is just square root of 2. And then you just, since the degree of the numerator and the denominator is equal to each other, you can just take 3 and square root of 2, and then you just get 3 radical 2 over 2.
Yeah, or you could see, you get x squared divided by x squared, something divided by itself. Something divided by itself equals to 1. Right.
Wait,
so
can you just
3
say you can cancel that, or I don't know if you can use the term.
Right, people usually like to say cancel out. You could use that, but in reality, it's something divided by itself, right? What's x squared divided by x squared? That equals to 1, right? So equals 1, 1 multiplied by anything will be anything. So you have 3 divided by radical 2 times 1. Well, that's just 3 divided by radical 2. So can you explain to us why your answer is 3 radical 2 divided by 2?
Since I didn't want just like radical in the denominator, I rationalized it. So I multiplied top and bottom by radical 2, so you get 3 radical 2 over 2.
Great. Yep. We need to rationalize the denominator because 3 apples shared by square root of people doesn't make sense. We like to say 3 radical 2 apple shared by 2 people. Because apples we can cut any amount we want, but people we don't want to cut people. Okay, all right, thank you. Thank you, Henny. Okay, I see 16. Oh, it disappeared. I saw 16 appeared, but now disappeared.
I apologize, Professor. I wasn't able to upload and my screen was freezing. I'll try to upload it right now.
Okay. It was there, but then it disappeared. Yeah, it appeared again.
No? Okay, so for number 16, we were asked to find dy over dx or either y prime for each equation. And
We lost your voice.
can you hear me now?
Yeah.
So for this question, we were asked to find dy over dx or y prime, and I used implicit differentiation. And the idea behind implicit differentiation is to multiply any expressions by y prime if you're finding the derivative of an expression containing y. So from here, I've tried to solve for the derivative of each expression. So it would be 3x squared minus y plus x times y prime. And I use the product rule to find the derivative of x times y plus 3y squared times y prime equals 0. From there, I subtracted 3x squared plus y and moved it to the other side so that I could separate the terms containing y prime on one end and then the other terms on the other. From there, I factored out y prime and divided both sides by negative x plus 3y squared to have y prime on its own to be able to solve for the derivative. And from there, I wanted to switch the terms so that the leading coefficient was a negative. So y prime equals to y minus 3x squared over 3y squared minus x.
Okay, great. All right, this is again implicit differentiation. Okay, thank you. Thank you, Noella. Next one. Malika. Yeah, sure.
Okay. Let me just upload the picture because I think it disappeared.
Hope everyone can present. All right. You see, once you understand what you're doing with the problem, it should be easy to present, right? Yes, Vaughn. If nobody did 4, you could do it. I don't remember all the numbers we have done.
Okay, can you see the screen?
Yeah, it's
Yeah.
22.
Yeah, it's 22. We have to evaluate the
22,
integral.
someone already did it.
I'm sorry, what?
22, someone already did it.
Oh, okay. Never mind then. Oh,
Yeah,
sorry.
it's okay. Okay, next one. Okay, I see 4 on the screen.
Okay. So, well, the question asked to find representation of f4. So we get this function when x is not equal to 4. And to find the representation, we have to rewrite the function. And we could do that by multiplying the numerator and denominator by square root of 2x minus 3 plus square root of 3x minus 7. And we get 2x minus 3 minus 3x minus 7 over 4 minus x times square root of 2x minus 3 plus square root of 3x minus 7. And then we get 4 minus x over 4 minus x times square root of 2x minus 3 plus square root of 3x minus 7. And we could cancel out 4 minus x since it's in the numerator and denominator. And then we get 1 over square root of 2x minus 3 plus square root of 3x minus 7. And that equation is for when x is not equal to 4. And to find a representation of f of 4, we just substitute x for 4, and we get 1 over 2 square root of 5.
Okay, the idea is right, but it's missing a very important piece. Let's go back to the function, right? We have 4 which is saying, do we have f of 4?
No, we don't.
No, we do have 4. Because in the end, you wrote f of 4 equals to this. Does that make sense?
Yeah.
No, you're contradicting with yourself, right?
Wait. What did you ask?
The function is defined as this in the blue circle.
Yeah. Okay.
So I said, can you talk about f of 4? F of 4 is not defined, right?
Yeah, in the original function.
Right. But now your conclusion is f of 4 equals to a number. Do you see the contradiction? So let's look at this picture, right? Let's look at the original function. So original function, can we talk about the f of 4? We cannot.
No.
No, we cannot talk about the f of 4. But your conclusion is f of 4 equals to a number. Something is missing in this. Your calculation is right, but it is missing very important idea.
That number is for when.
You know, when we remember what is the very idea? When we cannot talk about the value, when the value is not in the domain of the function, what's the very idea? Help us to do that.
Oh, do you mean when? So, the representation of f of 4 equals 1 over 2 square root of 5 is for when x does not equal to 4?
So I'm sorry, I do not understand. So you have to use what very important. Okay, can you tell me what we have learned in this course? I said 3 ideas, 3 concepts. Can you tell me the 3 concepts we have learned in this course?
Of continuity?
No, in the big branch.
Oh,
you see the one we just finished, it's the integration, right?
Oh, you mean the limits, derivatives, and
Right. So we haven't learned the limits, derivatives, integration, and integration. So this idea which one helped us to talk about a value, a number is not in the domain of the function?
Limits.
The limit, right? So can we use the limit idea into this question? Because we won't be able to talk about f of 4. F of 4 is not defined. So can you?
Oh, okay. So you mean like, wait, limit when x approaches 4, and then it would be f of x equals that.
That's right. Perfect.
Oh, okay, I got it. I understand.
Okay, that's the very idea. We need a limit. Great. You're able to rationalize yourself. Great. Thank you very
Thank you.
Great. Okay. Next one. Did we finish? Let's see. Okay. Okay, I see question 6. I think question 6 here. Did we show question 6?
I don't think so.
Okay, go ahead.
This is asking for limit as x approaches 0 of cosine squared 4x divided by 5 plus 2x squared. And for this problem, you can plug in x as 0, so then cosine squared of 4 times 0 divided by 5 plus 2 times 0 to the power of 2. So then for the top part, you would get cosine square root of 0 is equal to 1, and then below it you get 5 plus 0 equal to 5, and then it would be equal to 1 divided by 5, 1 over 5.
Right. So here we can write equal sign, right? Because once we plug in 0 into that, you can see this equals to the limit. This equals to the limit. We can put an equal sign among those.
Mm-hmm.
All right. Okay. Thank you, Stanley. Next one. Raphael, 27.
Yeah. So we're asked to take the integral of sine cubed x cosine x dx, and so I wanted to use the substitution rule because if we take the derivative of sine, we actually get cosine. We could cancel out the terms, so we get u equals sine x, and then we take the derivative of both sides. So du equals cosine x dx, and then you divide both sides by cosine x to isolate dx, so we can substitute it back in. So we get du over cosine x equals dx. So then we substitute back in. Right, so we take the derivative, the integral of u cubed cosine x du over cosine x, which we could cancel out the cosine x terms, and then we get we take the integral of u cubed du, which we get 1/4. Well, we use the power rule, right? So we add 1 and then divide by the exponent, so we get 1/4 u to the 4th, and then we plug back in. And since we don't have any upper bound or lower bound, we just add c, or an unknown constant, which we get 1/4 sine for x plus c, or you could write it the other way, sine to the 4th power x over 4 plus c.
Okay, so because you wrote equal sign there, you should, so 1 over 4 u raised by 4, you should add c already. So you're missing a c. Okay, add c. And another point is when we divide by our unknown, we have to be very careful. Here, let's try not to divide by cosine x. But we just check du equals cosine x dx. And cosine x dx in the integrand, right? Cosine x is integrand, in the integrand.
Yeah.
So,
That's true.
so because when we divide a variable, we have to be very careful because it can be 0.
Yeah, it can, yeah.
So let's not divide by cosine x, but just say du equals cosine x dx, then substitute. All right. Okay. All right. Thank you, Raphael. Next one.
Okay, Professor. So it's Amir here.
Okay.
So for I'm doing number 29, and we're asked to evaluate the definite integral from 3 to 0 of the absolute value of x squared minus 4 dx. So what I first did was I said x squared minus 4 equal to 0 and solved for the two possible values of x. So we have your x squared equals 4. And then we have your x is equal to 2 or negative 2. We know it can't be negative 2 because we're given 0 to 3. So from here, all we would do is we rewrite this. So the definite integral from 0 to 3, the absolute value of x squared minus 4 dx. So that would be equal to the definite integral from 2 to 0 of negative x squared minus 4 dx. And then what we would do here is we would add that to the definite integral from 2 to 3 of x squared positive x squared minus 4 dx. And then what we can do here is we can take out this negative right over here. So we can rearrange this to have 3, 2, x squared minus 4 dx. Then we have your minus. X squared minus 4 dx. And all we would do from here is we would take the antiderivative. So then we would have here x cubed over 3 minus 4x. And we would evaluate at 3 and 2. And then we would also subtract that from the definite integral from 0 to 2 of same thing. And when we evaluate this, what we would get in the end is this. Sorry. 0. You have your -3 plus 16 over 3 plus 16 over 3. And that would equal -9 over 3 plus 32 over 3, 23 over 3. That's your final answer.
Okay, looks great. But I would say here, after we integrated, right?
Yes.
Or after we do the antiderivative, you know, the convention is this.
Oh,
So
yeah, I'm supposed to put the line on the other
yeah,
side.
put 2 here, put a 2, 3 here, just by convention, you know.
Oh, so then this would be 2 and 0.
0, right? So just by convention, this is saying, you know, after integration, we don't need this integration sign anymore, but we put a bar on the right for the lower limit and the upper limit. Okay, great. So this is the integrated absolute value function, right? Or we could draw a picture of that. And the picture of that, the function would look like this. Absolute value function is always a v, right? I'm here already solved for us the 2 roots. So I have -2 here, we have 2 here. So we see, because we want to integrate the absolute value of it, so this lower part was negative, now has to be flipped into positive. So that's why he split into from 0 to 2, from 0 to 2, then put a negative sign in front of x squared minus 4.
Professor, I actually graphed the exact function. Do you want me to draw that or no?
No, you don't need to draw it, because if like here
Okay.
help you to figure out, you did figure out because you find a root. Because -2 is not in this from 0 to 3 interval. So you know this 2, you know from this 2. Well, it's always good to draw pictures, you know, to be visual. All right, great. Anybody has any questions? So this is a little bit difficult, you know, difficult problem. So Andrew is asking, why is it negative? Okay, I explained already. She did not understand. Amir, can you try to explain to her? Why sign?
So we would have your negative because on the absolute value we always have your don't you, I believe, wait.
Maybe that's why we want to use this picture. Okay,
Yeah,
and
because I
you
didn't
see,
draw the picture.
yeah, you see this picture. Okay, this value is -4 on y-axis, right? So absolute value. Oh, okay. My picture is not right because this is x squared minus 4.
Yeah, Professor, I actually have the exact picture if you could.
Should be this. Should be curve. Right? So it looks like this. Looks like a, you know, rounded x squared minus 4. So basically, just x squared lower down to -4.
Yeah, Professor, it looks something like this, I think. Like
The value be flipped up. Yes.
yeah.
So my picture is x squared minus 4. So x squared minus 4, but when absolute value, we have to put the absolute value. You see this part, the lower here. Let me shade it this region. It's been flipped above. It's been flipped above x-axis. Angel, does that make sense? Because negative become positive. That's why we need to put a negative, because this part, because we only do from 0 to 3, so forget about this side. So only 0 to 3, 0 to 3. Let's say 3 is here. So this is a 3, right? From 2 to 3, we say is above x-axis. So that's why we need to split into 2 regions. From 0 to 3, we need to split from 0 to 2, and from 2 to 3. From 2 to 3 is above x-axis. It's positive itself. It's positive itself. But from 0 to 2, we see is under this. We need to make this positive. We need to flip this above, so we put a negative sign in front. Does that make sense, Andrew? This is to deal with when the integrand is absolute value. All right, when the integrand is absolute value function, we have to figure out which part is negative, which part is positive for the function inside the absolute sign. All right, great. Thank you, Amir.
Thank
Next
you,
one.
Professor.
Okay, 26. Malika.
Yes, so for 26, we're asked to evaluate the integral. And for this question, I used the U substitution method. So U would be equal to 3x minus 5, and then du is the derivative of U. So the derivative of U would be just 3 because the derivative of negative 5 is just 0. And then I solved for dx, and then I got dx equals to du over 3. And then with all the variables that I got, I substituted it into the question. So I got integral symbol cosine of u times du over 3. And then you could see that you could take out 1 over 3. So that's what I did. I took out 1 over 3. And then you would need to integrate cosine of u times du. And then I got the antiderivative of cosine u would be sine u. So that's what I did. And then you need to add c since it's not definite, it's indefinite. So you add c. And then once you figure out the antiderivative and everything, you just substitute the u back into the function. And then I got 1 over 3 sine times 3x minus 5 plus c.
Yeah, you just substitute back u as x minus 5. Okay, looks great.
Okay, thank
All
you.
right. If anyone has any question at any moment, feel free to speak up. Okay, thank you, Malika. Who's next one?
So we're trying to find the limit of sine x plus sine x when x approaches 0. So I just plugged in 0. So when you plug in 0, sine x equals 0 is 0 plus sine 0. Sine 0 is 0, so sine of 0 is basically 0.
Yeah, that's it. 0 is in the domain of sine function. So you can just plug in 0 into the function. Okay, that's it. Thank you, Jason.
Thank you.
Next one. Maybe we finished? Everybody presented? Okay, I see some of you being silent in this class here, and you do not have enough presentation. And I think the question is getting difficult and more difficult as time goes along. Yeah, Amir, you did pretty well. And so anyone else? Oh, actually, we don't have time anymore. It's almost time. Okay, just so please, some of you have done a wonderful job. All right. So we're approaching to the end of this semester, but we still have time. We have like 2 more weeks to work on this. So if any of you have any question, or also some of you have gone for help from the math center. They did send me a list of students, went to them for help. I remember Raphael and Chen Yi on the list. So if some of you still have a lot of questions, go to Math Center. I think I posted in the Blackboard, right? Ask them for help, for helping you to do the homework, because I won't be able to help you to do the homework or do the review sheet, right? But if you ask tutors can help you with that, and also with presentation. With presentation, I can help you, right? I'll point it out, I'll ask you, because when you present, you have to understand what's going on. But I think, some of you or most of you have done a wonderful job. All right, so keep doing the review sheet, and we'll, keep presenting. And again, simplify. We only learn the limit, differentiation and integration. Everything is under these 3 concepts. All right, okay. I see you on Monday, all right? Have a good weekend.